Good morning everyone, myself Pavitra. I am working as an assistant professor MCA department in MIT Mysore. Today I am going to give a session or presentation on the subject what I am taking for third semester MCA students. Before getting to that subject, I would like to tell the mission of our college and our department. So the main aim or vision of our college is to be recognized as a premier technical and management institution promoting extensive education, fostering research, innovation and entrepreneurial attitude. The mission of our college is to empower students with indispensable knowledge through dedicated teaching and collaborative learning, to advance extensive research in science, engineering and management disciplines, and to facilitate entrepreneurial skills through effective institute industry collaboration and interaction with alumni, to instill the need to uphold ethics in every aspect, and the last one is to mold holistic individuals capable of contributing to the advancement of the society. Again, the mission of our department. The vision of our MCA department is to be the premier source that provides a transformative education to create the computer professionals, competent entrepreneurs and technocrats to meet the goal challenges. The mission of our department is to facilitate students to nurture skills to practice their professions competently to meet the ever-changing needs of society and environment, and to develop the potential of human resources with new ideas, research to meet the requirements of cutting-edge technology. Now I am going to get into that subject what I am going to take for MCA students of third semester. In this semester just I am going to take the subject, it is system software. It is having 5 different modules. The subject code of system software, it is 18MCA34. It is having 5 different modules. Just I want to get into that subject. So the module 1, it is machine architecture and the introduction to assemblers, and the module 2, it is assemblers. The module 3, it is loaders and linkers. The module 4, it is microprocessors, and module 5, it is compilers. So the textbook just you need to refer, it is Leyland L. Beck. The textbook name, it is System Software 3rd edition. So the main objective of this course, so the student can understand the basic design of the machine architecture. So just I am going to explain what is machine architecture, what is system software, what is software, everything just I am going to explain in upcoming sessions. The main objective of this course, which is used to for the students to understand the basic design of the various machine architecture. Again, the students, it is having built the ability to design the assemblers, and the student come to know that importance of the various components of system softwares. Various components means loaders, linkers, microprocessors and compilers, assemblers and all. Right. So the main course outcomes, there are four course outcomes are there in system software. The first one, it is just we are going to understand the introductory concepts of system software and the different kinds of machine architectures we are going to learn. That is the SIC and SICX machine architecture, VAX architectures, Spark architectures. We are going to learn different kinds of architectures here. The second one, it is understand and the design and implementation of assemblers using some kind of implementation examples. That is pass 1 assembler, pass 2 assemblers. So here just we are going to understand the design and the implementation and the working procedure of assembler in that subject. In CO3, it design and implement the linkers and loaders, microprocessors and respective implementation example along with the algorithms, the working procedure of those loaders, linkers, microprocessors and the linkers. And at last we are going to learn the basic design of the compilers and the working procedure of the compilers. So by studying these subjects, we can understand the complete knowledge about how actually our system will work by using different kinds of system softwares. Okay. So now I want to get into that the introduction to system software. So before getting to that one, I would like to say, I want to know what is software. So as we know that the program is nothing but is a collection of instructions. Collection of instructions means which is a collection of instructions which perform a specific task, that is called as program. Then what do you mean by software? What do you mean by software? Software is nothing but is a collection of programs, to perform a specific task. Program is nothing but is a collection of instructions which is used to perform a specific task. Software is nothing but is a collection of programs which performs a specific task. So means, then what's the difference? What kind of softwares which are available? So mainly we can categorize that software into two types. One is application software and another one is system software. Now I will get into that elaboration. So the software, it can be categorized into two types. One is application software and another one is system software. So the software is going to be categorized into two types: application software and system software. What is application software? What is system software? Application software is nothing but that is a general purpose program or collection of programs is written by the user to solve a particular problem. It might be any kind of softwares. It might be some kind of product based softwares or some kind of service oriented softwares, right? So here the software which is going to be developed by the users for a specific task. For example, some kind of projects or applications which are developed by yours, some kind of gaming applications, some kind of the applications like spreadsheets, like that. Again, some kind of applications like library management system, like that. So these are all called as application software which are built, a software which it is nothing but it's a collection of programs which is used to perform a specific task which is mainly developed by the user for a specific task, that is called as application software. So then what is system software? Without system software, can we execute our application software? No. For building an application software, as we know that we need different kinds of platforms. We need some kind of languages, that is the programming languages, some kind of backend, some platform, some IDE. We need get all those things. So after constructing that program, after constructing our application, yes, of course the applications must be executed by the system software. The software, that applications must be compiled, that applications must be executed, that applications must be loaded into the memory. Everything is going to be done by the system software. Then what is system software then? What is system software then? So, system software is nothing but it consists of a variety of programs that supports the operation of a computer. Again, it is going to providing a platform to execute the user applications or application programs or application softwares. System software is nothing but it's a collection of programs which is used to control the computer system, as well as it is going to providing a platform for executing the application softwares, the different kinds of applications softwares which are developed by the users. So before going to that one, so just I want to explain what are the different kinds of system softwares which are available, what are the main tasks of such kind of things. So as we know that when we are going to write a program, whether it is C program or C++ program or some kind of Java program, and whatever it might be, it is having its own language. It is having its own language. Some it is procedural oriented or some kind of object oriented language. So it is having its own syntax. By using such kind of syntax, just we are going to written that program, we are going to write the program by using different kinds of languages, right? So suppose in C programming, if I want to print a statement to the output screen, just we are using the printf statement. Within that printf statement, it is having some kind of string. It's to be displayed onto the screen. So this language, it can be understood by me, but the same thing is going to be understood by the computer? No, the computer knows only that binary language. How actually, who is going to convert that statement into the binary language? Yes, exactly, that is system software. So there are different kinds of system softwares are there. So what are those? Is assemblers, or sometimes we are also called as compilers, then loaders, linkers, and compilers, sometimes text editors. Those are all called as system softwares. What are those assemblers, compilers, what loaders, linkers? Why do we need such kind of things? So in this case, whenever the user has written some kind of program, that program must be executed, isn't it? So that program must be executed. If the program needs to be executed, yes, of course, that program must be converted into object code or binary code. After that, after converting that object code, yes, of course, that program must be loaded into the primary memory for its execution. So once it's executed, so then it is going to give some kind of exe file. For example, when we have written some kind of C programming, before that the source code, the source file of the C program is nothing but is like the extension file name dot C. Otherwise, I'll take sample. The program name it is sample. The extension it is either C or CPP and whatever it might be. So when that program is converted into object file, so it is having, just we are going to having that object file. It is in the form of with an extension obj. That is the object file. So once the object file is ready, then that object file must be loaded into the primary memory for its execution. After the execution of that program, the same file it is there in the form of exe with an extension exe file. So here, how actually it is going to convert? What actually, who is going to do all those things? Yes, of course, the system software. That is the assemblers or compilers, loaders, linkers, and what such kind of things. In this case, so here, whatever the source code, just what we have written in the higher level language, that will be the input. That will be the input to the compiler first. So the compiler, it is going to generate a sequence of tokens accordingly what kind of language it is. So the C programming language, it is having its own compiler. Java programming language, it is having its own compiler. C#, it is having its own compiler. Every language, it is having its own syntax, grammar and all. Accordingly, the compilers has been designed. If it is C programming language, it is going to parsing, it is going to scanning each and every line. Again, it is going to generate the sequence of tokens. So once the object code is being generated by the compiler, the next is the assembler. The object code, the compiler, what is the main task of the compiler? Which is used to convert the higher level language to machine code level language, means that is the object code. That is the object code or assembly code we can say. There is a difference between the object code and the assembly code. We'll let you know what is assembly code and object code in the later session, right? So here, just it is going to generate the assembly code here. Then whatever the assembly code which is generated by the compiler will be the input for the assembler. The assembler is going to generate the object file. So the object file, it is in the format of what? Some kind of hexadecimal representation or some kind of binary representation. So once the object file is been ready, so the next task is for the linkers. So what is the main task of linkers? Just it is going to link some kind of predefined routines which are required for that particular program. For example, if you are including some kind of header files, that is stdio.h, conio.h, math.h. So those are all called as predefined functions or predefined library functions. At the loading time only, the linker is going to link such kind of routines to the program or to the whatever the program just we have written. So the linker is going to do such kind of things. It can link either predefined routines, otherwise some other object file to the existing file. So this is the main task of the linker. So the linker is going to generate the executable file. It is going to generate the executable file. Finally, the loader is going to load that program into the primary memory for its execution. The loader is going to load the same program into the primary memory for its execution. So that is called as, this is how actually the source code, it is going to be converted into executable code by using system software. So means whatever the program we have written, by using different kinds of languages, first it is going to convert it into assembly code, so then it is going to convert it into object code, so then it is going to link, the linker is going to link some kind of predefined routines and some other assembly code to the existing program. Finally, then it is going to giving the executable file for the loader. The loader is going to load that same program into the memory. So next I want to know that what is the relationship between the system software and the machine architecture. So in the first module we had seen introduction about the different kinds of machine architecture and what the system software. Yes, of course, the system software, the designing of assembler, designing of compilers, it is different from one machine architecture to different another machine architecture. Some of the system software, it is machine dependency, and some of the system software, it is generic. It can be worked on any machine architectures. What is machine architecture? As we know that when it comes to that machine architecture, the main aspects we can talk, for the machine architectures, it is the memory of that, what is the primary memory of that machine, which can hold the number of processes to be executed. Again, the CPU registers. So the CPU registers, it is varying from one machine architecture to another machine architecture. So in the hypothetical machine architecture, there is the SIC machine architecture. It is supporting only 5 different kinds of CPU registers. It was not having any kind of general purpose registers there. So it is the number of registers, the CPU registers, it is varying from system to system. So accordingly, that's what assemblers and compilers are going to be designed, because while executing such kind of things, it is making use of different kinds of CPU registers. The CPU registers, it is of 2 types, that is the special purpose registers and the general purpose register. Special purpose registers is nothing but program counter, memory address registers, memory data registers, accumulator, instruction registers. These are all called as special purpose registers, and the general purpose registers, which is used for storing the intermediate data. So the number of registers, it is varying from one machine architecture to another machine architecture. And another thing, it is instruction set. So there are different kinds of instruction sets which are available. It is also varying from one machine architecture to another machine architecture. Instruction set, then data formats, the representation of the different kinds of data. What are the different kinds of data? It is integer, float, character, strings, like that. So here also it is also differ from one machine architecture to another machine architecture, and the instruction format is also matters. Instruction format, what is the instruction format? The length of the instruction format, it is also varying from one to another. Again, instruction format and the addressing modes, this is most important, that is the addressing modes. There are different kinds of addressing modes, as we know, the direct addressing mode, indirect addressing mode, index addressing mode, some kind of program counter relative addressing mode, such kind of addressing modes are there. So the addressing modes is also differ from one machine architecture to another machine architecture. We are going to learn all those things in the upcoming sessions. So these are all when we are talking about that machine architecture, we should know the main aspects of the machine architectures, these kind of things. It is varying from one machine to another machine. So hence some of the system software, it is depending on the machine architecture and whatever the system softwares which are designed generically, which is going to run on all the systems. Some kind of code optimization technique, otherwise some general concepts of general logic of the assemblers. It may not varying, but while converting the mnemonic values into the opcode or object code, is of course it should making use of the CPU registers. So for that, the number of CPU registers and what kind of CPU registers which are available in that particular machine architecture, it matters. So hence the system software, sometimes it is machine dependent, sometimes it is not machine dependent. So in the upcoming sessions, just I am going to do the complete introduction about the syllabus and whatever the modules which are there. Thank you.